Hi everyone, my name is Jack Fan, and today I'm gonna go through the public health case study activity that I planned and run for my individual project for Latham Science Engagement Fellowship Program a couple weeks ago. It was a very unique opportunity for local high school students to be involved in this activity and to have a basic understanding of public health. So the activity is called Epidemic Simulation. So the students will simulate the transmission of infectious disease through the classroom and determine the original source of infection. And students will also create graphs that depict the exponential growth in the number of persons infected. So the objectives of this case study activity is to ensure students will simulate the transmission of disease. That's the number one. The second, students have a basic understanding of how how infectious disease take place among individuals in reality. And third is students should understand and graph exponential growth. And fourth, students will have the ability to determine the source of pathogen. So next, I'm gonna show you the materials and the equipment that I use for this demonstration. Okay, so this is a set of kits that I use for these epidemic simulation activity for local high school students. And as you see, this is hydrochloric acid, this is a phenol red, and this is sodium hydroxide, and there are the caps for the vials and the pipettes and the well plates and a marker here and an index card. So the materials are not really special. They're just very easy, accessible chemicals and some equipments. So yes, let me just tell you how this activity was run. Hi, so I spent 15 minutes around to prepare all of the materials for students to be involved in this epidemic simulation activity. And at the conference, we spent around 45 minutes to run through the whole activity. So in my preparation, I prepared 30 vials and I number each of them 1 to 30, and I pick a random vial with a random number as an affected vial, and I put that affected vial aside, and in each of the other 29 vials, I placed 2 milliliter hydrochloric acid using a pipette, and so using pipette and 2 milliliter, and make sure I kept the vial securely, and also in the affected vial, I drop 2 milliliter sodium hydroxide to the affected vial. And also I had a marker. I make sure label the well plate from 0, 1, 2, and 3. So the well plate is used for students to put their original fluids and mixed fluids after rounds of fluid exchange, and eventually we will add the drops of phenol as an indicator to see which vial has been infected and which vial is the original source of infection. So regarding the activity, so students arrive in the lab and I hand out this index card to each of students, and they will have a pencil. Also, I hand out each vial to each student, making sure the affected vial is being used. And I inform the students of vials containing the clear solution that represent the body fluids. So they will have either hydrochloric acid, which is actually the majority of students will have, or they will have sodium chloride, but both of them look the same, right? And they will be exchanging the liquid in the vials with those of other students in the class to simulate the direct contact between individuals in disease transmission. And then I instruct students to drop 5 liquids from the vial 5 liquids from the vial to the plate labeled 0. The 0 plate actually is considered like a sensor solution plate, because that they put their own solution into the plate 0. Those solutions in the plate 0 are actually the ones before the body fluid exchange. So that's very important in terms of identifying the source of infection in the end. So, and then I instruct students to pick up a random partner, write down the partner's name, vial number, and the exchange of fluids. And that's the first round of body fluid exchange. And then after, make sure to drop 5 liquids of their new mixed solution after the first round of body fluid exchange, and put it into the plate number 1. And so we did actually several rounds. We did actually 2 rounds, and then in the end, after all of the exchange have been made, I, as an instructor, added 1 drop phenol red to each student vial, and vials that turn red or are positive for the pathogen, and the vials that turn yellow are negative, which means those students who have the yellow vials after adding this phenol red are uninfected. So then I encourage students to narrow down a list of the student's name that they think might be the source of infection or might be not, looking at which vials have been turning pink or red, or which vials are not, so I had students develop and carry out procedure for using the data available to determine who was original infected vial. So I also reminded students that if a person who tested positive at the end exchange with a person who tested negative, then that positive vial can be eliminated as the original source of infection. And yes, so once students actually have identified or determined the 2 potential sources, then I can add the phenol red solution into the well plate 0 to see who was the original source of infection. So this activity was actually running smoothly, and it makes sense to students based on student performance. So this is actually just the activity that I run. If you have any question, please feel free to reach out to me, ask me in person at the table on Saturday Latham showcase. So I look forward to meeting with you, and look forward to answering your question. Thank you so much.